Welcome to Are There Aliens? The big question that's fascinated humanity for centuries. I'm Universions, and today we're diving into the Drake's equation, a groundbreaking formula created by astronomer Frank Drake in 1961 to estimate how many intelligent communicative civilizations might be out there in our Milky Way galaxy. Picture this, an alien drifting through the cosmos. But is it just science fiction? Let's crunch the numbers and find out. First up in the Drake equations is R star, the average rate of new stars forming in our galaxy each year. Based on modern observation from telescopes like Hubble and Gaia, we estimate this at about 1.5 to 3 stars per year. It's the starting point. Without stars, no planets, no life. Next is FP, the fraction of stars that have planets. Thanks to missions like Kepler, we now know this is exactly 1. Almost every star has at least one planet orbiting it. Our galaxy is packed with potential worlds. Then there is what we call NL, the average number of habitable planets per star system, those in the Goldilocks zones, where liquid water could exist. Current data suggests 20 to 40% per system. Not every planet is an Earth-like, but there are billions out there. Then it's FL, the fraction of those habitable planets where life actually emerges. This one is trickier. On Earth, life started pretty quickly after the planet cooled, so estimates range from 13% to nearly 1. Could life be common if conditions are right? Then it's Fi, the fraction where the intelligent life evolves. This is where it gets speculative. On Earth, it took billions of years and rare events like mass extinctions. Estimates vary widely, from 3 out of 10,000, super rare, to 1, which is inevitable. Are we a cosmic fluke? Then it's FC, the fraction of intelligent species that develop technology to set signals into space, like radio waves. We assume 10 to 20%. Not every smart civilization might broadcast, or they could use technology we can't even detect yet. Finally, we have L, how long this civilization lasts while sending out signals. This could be short, like 300 years if they're fragile like us, or tens of thousands if they survive wars, disasters, or even self-destruction. It's the big wild card. Now putting it all together, N equals the star forming rate times the fraction of stars having planets, the fraction of life supporting planets, fraction of actually habitable planets, fraction of actually intelligent civilization exist, fraction of actually intelligent civilization developing communication technology, and mean length of time that civilization can communicate. According to Kepler telescope, we know that every star has one planet orbiting it, and that's a huge deal. Now, we have to mention this isn't a crystal ball, it's just a framework to think about our place in the universe. But the real fun is in the estimates, depending on optimistic or pessimistic views, and could be 0 to a few thousands. So let's start with a pessimistic scenario, the rare Earth view. Using low estimates, our star can be 1.5 stars per year. Then we have FP, which is 1, as we said by observation of Kepler. Then 20% have habitable planets. Therefore, the habitable planets are 30%. With those that they have life, it's 4%. With intelligence is 1 per million and communicative 1 per 10 million. Adjusting for our lifetime, we get 10 to the minus 5, 4, which is a nearly 0 estimate. We might be the only ones explaining the eerie silence of space, known as the Fermi paradox. Where is everybody? Now, a moderate take, balancing hope and realism, with an R star of 2 stars per year, we have that there are stars with habitable planets at 60%, with life only 30%, with intelligent life only 3 per thousand, with communicative only 4 out of 10,000, and adjusting for our lifetime of 400 years, we get 2%. And this suggests that it's only less than one civilization, suggesting they're out there but incredibly rare. Maybe we just missed their signals or they're long gone. And finally, we have the optimistic scenario. Life finds a way. We have 3 stars per year, and then stars with habitable planets are going to be 1.2, with life against 1.2, intelligence 1.2, but communication it's only at 20%. Therefore, we have only 24% of those planets to be communicating with us. Adjusting for a lifetime of 10,000 years, we get only 2,400 civilizations out there, but they are spread across 100,000 light years. Communication could take millennia. Exciting, right? Telescopes like James Webb might soon find clues about those civilizations. And let's keep wondering. Hey Cosmic Explorers, let's keep crunching those Drake equation numbers. Islands out there, or maybe right here among us blending in. Stay vigilant, stay curious, and the universe is full of surprises. So, are there aliens? The Drake equation shows it depends on our assumptions, from loneliness to a cosmic community. Science is advancing daily with new discoveries. What kind of scenario do you lean on towards? Drop a comment, like, and subscribe for more space adventures. Thanks for watching and keep looking.